So good morning again and welcome back. So to introduce to you our next presenter today. So actually he's one of our DJP close associates, especially for Reflow soldering for the past 15 or so years. So to present the new generation Tamura Reflow system, may I introduce to you Mr. James Chai from Tamura, Singapore. James,
Good
okay, you
morning.
may proceed.
First of all, I would like to introduce myself. My name is James Chai from Tamura Corporation, Singapore. And my company is dealing with electronic chemicals like solder paste and flux, and also the soldering equipment.
James.
Yes.
Hello, can you hear me, everyone? Maybe I will start with sharing our product video.
We'd like to introduce the TNV version 3 series, which is the latest model of our Reflow soldering system to respond to customers' needs. We believe that improving production efficiency is our most important task among all our customers' needs. Therefore, we focus on reduction of maintenance frequency, energy saving, and responding to IoT, and have improved our product to the highest level in the industry. First of all, let's introduce the reduction of maintenance frequency. Cleaning the dirt caused by flux in furnaces requires a lot of time and labor in particular. When heating the mounted substrates, various fumes such as flux are generated in the system. We reviewed the mechanism of dirt contamination and worked to avoid producing pollutants, allowing adhesion, or allowing remnants. We specified the parts that produce flux fumes using convection control technology that leads air to flow efficiently and contributes to the reduction of maintenance frequency. According to the result of field tests, the cycle has been expanded 2 to 3 times. Next, let's explain energy savings. Thanks to the furnace convection control, atmosphere stability in the furnace has been improved drastically. It is easier to manage the oxygen concentration in all zones under 1000 ppm during continuous substrate conveyance. In addition, by optimizing both software and hardware, such as startup system improvements, we have achieved an industry-leading level of reduction of nitrogen consumption and electricity consumption. Third, responding to IoT. Towards the sustainable development of IoT, we have been strengthening the collaborations with mounter makers, working on automatic setup switching functions of all related companies, and coping with production control systems. This is the performance comparison with an existing model. Thanks to the newly developed furnace convection control, we are able to shorten the maintenance cycle and reduce the flux drop on substrates drastically, which is a big contribution to the reduction of running costs for our clients. Last, please allow us to introduce the lineup of the TNV version 3 series. We set up 8 zones, 10 zones, 12 zones on the M-size model with a maximum substrate width of 300 millimeters, and the L-size with a maximum substrate width of 510 millimeters, which are both dual-lane type. We will keep on innovating the Tamura Reflow soldering system to improve the production efficiency for our clients. We are always aiming for reflows at the world's highest level, and we sincerely hope that you will consider purchasing our latest high-performance reflow soldering system. We seek to reduce production opportunity loss wherever possible through the reduction of maintenance frequency and energy savings that are achieved through the reduction of nitrogen and electricity consumption. We will also seek to respond to IoT as much as possible going forward.
switch PowerPoint. Give me a second. So today I would like to present you our latest model for TMV version 3. So today I have 3 subjects to discuss. Firstly is what customer want for SMT production line. Second is the concept of Tamura new products and also the feature of the new products. This is a part 3 to making a good reflow system, but today I'm emphasizing on making the third in the oven, means the flux issue in the oven, and secondly is energy saving and also the reduce of the N2 consumption for best oxygen density level performance. And lastly is IoT, traceability, functions, and so on. This is the market research from the JETA in 2017. The first request from market from the customer is maintenance-free lights for the flux collection system. Based on this requirement, we have reviewed our TMV design for the version 3. Firstly is the maintenance-free, secondly is the energy saving, and also the enhanced IoT. For the maintenance-free, presently the customer has facing the 1:1, 2:1, or 1:1 for the cleaning, downtime for the machine for the cleaning of the flux. But as for our version 3, we enhance or prolong the cleaning up to 3 months once. In future, we would like to challenge ourselves for 6 months once for cleaning. This is a typical reflow process. When PCB pass through the oven, there's a lot of frames will be produced, and all these frames will form up from gas form, become liquid at the inlet area, and also the cooling zone areas. So after cleaning of the reflow, the cooling panel become clean. But a month later, the flux stain become accumulation at this cooling panel. If customer don't clean it in time, the excesses of the flux will be formed and drip on the PCB and create the defect. So I would like to share you the relationship. Where is the flux come from? Flux residue come from. The red line represents the lead-free profile, and blue line represents the mass of the solder paste printed on the PCB have been reduced. When at the end of the preheating, the mass have been lost 12.5%, and further loss down to 18.5% when the temperature reach at the peak temperature. Then throughout the whole process, the solder paste weight have been lost 27.5%, which means 1/4 of the paste printed on the PCB have been lost and form of the flux residues and stuck in the oven. And we have been collected both substance from the oven. At the preheating area, we collected the solvent from the solder paste. At the reflow zone areas or the cooling zone area, we collected the rosin from the solder paste. And this is more dark in color and more sticky and more difficult to clean. And this is our color models, TMV version 1 designs. So there is a 2 flux collider installed, and total of the flux collection rate at 5 plus 10, total of 15. And the cooling panel at this area easily formed with a flux stain. As for the version 3 designs, we have increased the flux collider from 2 units into become 4 units. We add in additional 2 units at the heating, at the preheating, and also the reflow zone area. With a convex flow design, and he helped to minimize the flux leak at the inlet and also at the cooling zone area. As you can see, the cooling panel still remain clean after a month of the testing. And this is a few tests from one of my customers. The first 2 colliders, flux collider units, have been collected the solvent. That's why you can see the color of the solvent still in liquid form and quite clear. And compared to the reflow zone and also the cooling zone area installed in between the heat and cooling area, the solid flux have been collected at this flux collector. And this is continuously run for a month, 24 hours process. With the improvement of the flux collection rate up from 15 to 50%, it helped to make the oven inside become clean and reduce the flux jam at the leak screw area, at these areas. So the downtime for the machine also reduced. Second topic I would like to share with you about the power saving and N2 saving, and also reduce the startup time. For power saving, there is 2 concerns: to reduce the heat release from the oven, or the heat load dropping, or reduce the heat load actually. So we have improved the insulation, also reduce the radiation areas. At the same time, we also increase the heating efficiency, also high load restraint. And there are so many things we have had to put in effort to improve the good system. And today we are emphasized on these areas. How we make it, I will explain in the next slide. For version 3, since we have increased the flux units from 2 units to 4 units installed in the system. Basically, the power consumption have been go out. As you can see from the heating display, you can see the bar. The blue bar represents the power have been input into the heating zone. At the zone 1, zone 6, zone 7, zone 8 have been increased power consumptions. But with further improve of the heating control method, and also the excuse me, and also the N2 efficiency use, and also flux collection process and optimization flow and blower control optimizations. We have been great improved for the waiting time, heating up waiting time from 60 minutes down to 35 minute waiting. And the power consumption also slightly dropped from 8.36 kilowatt to 8.21 kilowatts. Next, come to the N2 consumptions. For version 3 design, ozone ppm are able to go down below 1000 and below. with a 250 liter per minute supply of the N2 gas. And this is our typical PCB size we use for testing and the power setting. With this convex flow design integrated in the version 3 system, we help to plug the external air into the oven, also keep the flux stream and the N2 inside the oven, so that at the end of the result, N2 consumption is reduced. Let me show you in this next slide. The present models, air is easily fall into the oven. For version 3 is being blocked. And this is the N2 density we have been measured. For previous models, this is the performance of O2 ppm for each zone area. This is to represent the reflow zone area because this is the mean supply of the N2 locations. And this cooling area and the cooling zone areas. So you can see different locations have a different O2 ppm performance. As for version 3, with a convex flow design, all the heating zone areas, we keep maintain the O2 ppm at 1000 ppm and below, which means you have a great save for the N2 consumptions around 80 to 95%. And this is a color models. The performance of the N2 have been leaked and air also easily to come in. For version 3 models, air and N2 have been separated by the convex flow design. Lastly, I come to the IoT. Our version 3 design is all integrated with IoT functions. It's integrated to work with Panasonic IRMB system as well. So he comes with the auto change setup just in time mode. The product ID has been scanned, and then each following machine will be changed the parameter, process parameter automatically. And auto change by the PCB ID mode. If a PCB ID has been scanned, the machine also change accordingly. Lastly is the traceability for every PCB running in the productions. So in our reflow system, in front of it, we install the barcode to detect the PCB ID or running numbers. All the PCB ID and set point and present value will be installed into the IRMB server automatically. So this is a conclusion for our previous compared between version 3 and our previous models. Our previous models are used to have 20 kg of solder paste used in productions, and you need to do the cleaning. But we have improved up to 240 kg of solder paste use and prolong the maintenance cycle up to 3 months once. This is due to the convex flow design have been installed, and then the flux, and also increase our flux collector from 2 units to 4 units. So the flux collection rate increase 3 times, almost 3 times, from 15% to 50%. The flux stain stay on the cooling panel from 3.7 gram also dropped to 0.1 gram. And power consumption also slightly dropped. And N2 is a great dropping from 400 liter, dropped to 250 liter. And waiting time also shortened from 60 minutes to 35 minutes. And this is our layout. We produce 8 zone, 10 zone, 12 zone. This is 8 zone means for heating zone only. And we have 1 cooling zone for 8 zone. And as for 10 zone and 12 zone, we come with 2 cooling zone. So we make M size board, maximum width up to 300, and L size board, maximum width, PCB width up to 510. And we also have a dual type and twin type. The difference between the dual means between dual and the twin. This is a single heater for dual link, and this is a separate heater for separate temperature control. We call it twin type. And twin type, the advantage of using the dual type, dual used to have a 2 single reflow installed in the production line, and you can reduce the workspace. Production space have been saved by using the dual reflow. So you can save the area about 36%. And this is the structure of a dual type reflow. A single heating zone with a 2 lane of the solder link, conveyor link. Each conveyor link maximum up to 250 mm each. And this is how structure look like. And come to the twin. Because the twin have a slightly bigger of the machine width. Therefore, the area have been reduced about 32%. And this is a structure like for twin type. We install the wall to separate the 2 heater, 2 links. So each link, you can have a setting of the separate setting of the temperature and conveyor speed. Of course, a different profile you can choose to use. And each PCB width is 330 mm each. And this is differences. You can set a different temperature.
Thank you, Romeo.
For the link one,
Okay.
for the link one, you can do the.
And Mr. Potat from DJP, Mr. James from Tama, Singapore, Mr. John from Mekatoro. Thank you very much for today's wonderful presentation.
This is a typical level profile. You can see the setting value,
ladies and gentlemen.
and there is the curing profile. You can see the differences in between, maybe set around less than 100 degrees is possible. And you still can maintain a good LDT for each profile. The advantage for the dual or the link, twin reflow design, we have changed the hook opening from inclined angles into the elevator type, horizontal up-down movements. This is to improve the easy maintenance for the user, which means the user can stand in front or the rear of the machines and do their maintenance easily. Unlike last time, someone had to lie down and stretch their body into the reflow areas, the bottom area, to do the cleaning. I come to the end of my presentation. Thank you for listening.